All right. I just got the note that we are live. So I believe we can get started. I'm going to give it a minute or two for people to filter in, and I'll just start by introducing myself. Hello, my name is David Awad. I am one of the wonderful developer evangelists here at R3 working on Corda. I have with me another one of my colleagues from my team, Peter Lee, who is going to be in the chat. He is also a developer evangelist. So if you have any questions about anything we're going to talk about today, feel free to throw them into the chat. Peter will be there, and we'll tell you guys all about how you can find us and get in contact with us for anything you're working on after this. So by all means, feel free to ask any questions. We're here for you, and we're happy to support you. That being said, today we're going to talk about the Corda SDK, or sorry, the Corda token SDK. So we have a small workshop. We're going to do a quick recap of a little bit of the Corda basics, and then we're going to talk a little bit about what tokens are and a good kind of mental model for you to use when you're thinking about them. And then we'll segue that into some explicit examples, and we'll look at some code as well. So hopefully all of that preamble is laid out clearly on the table, and we can get right into it. So I want to start by talking about, I want to start by asking all of you for a quick poll. If you could put in the chat, just give us a sense of your experience with Corda so we can better understand who we're working with. Just put in the chat a quick number, 1 through 5, 5 being very experienced with Corda, and 1 being a complete newbie. No shame if you are a newbie. We just want to better understand how we can produce content for you guys. So if you could just post in the chat really quickly a 1 through 5, 5 being the most experienced with Corda and 1 being not very experienced. So that being said, I'll jump into my quick recap on the basic components. So in general, you want to think about 3 things when you're dealing with CorDapps. There are Corda states, there are Corda contracts, and there are Corda flows. So when you are thinking about representing any asset on a blockchain, the state tends to be the object itself. That is your car, a house, $200, etc. A state is really anything you could represent inside of a Java or Kotlin class. So if you can represent it in an object-oriented fashion, you can probably use Java to create a class that extends the state abstraction that we give you with Corda in order to create an object you can store on the blockchain. Keeping that in mind, any object you can represent in your code as a state, it gets consumed, it gets updated, and it gets stored. A good example of being consumed might be, let's say there is a loan between 2 people, and I pay $3 on that loan. So that previous state of the loan, if you will, is consumed, and the amount of the loan is updated to reflect that $3 differential. And then a new version of that state is produced. We use this unspent transaction output model with respect to the way we think about blockchains. So that would be worth a quick Google after the fact, after we're done here. So again, you can create states, it can be updated, and then they are stored on the blockchain explicitly only between the parties that are part of those transactions. So that being said, that brings us to what a contract is, right? I just gave you the example of a loan where you can pay money on a loan, and that would be an example of the kind of transaction that a contract verifies. So a contract basically is a series of rules that outlines the validity of a particular kind of transaction. So for example, if I issue someone a license plate for their car, I live in New Jersey myself, and so in New Jersey, every license plate for every vehicle has to have 6 characters on it, and so that might be a good contract rule. So within my contract, if I try to create the transaction to issue a license plate, I would need to make sure that the license plate number has 6 digits. And so you can see how this can get extended, right? If contracts can verify anything that you can do, you can have things like contracts for verifying payments to people where the payment amount has to be positive or non-zero. Another one being that, let's say I'm selling something from one person to another. Okay, so there must be an input state to that. I did not magically gain the ownership of an object such that I could sell it. So I have to actually have it, and I can use the blockchain to trace the history of that state or that object to my ownership, and then be able to sell it to other people that way. So that ownership is an explicit precondition. So you might say that there has to be an input state to a transaction. So this is kind of what contract rules are all about. Contracts verify what are the things I can do with an object, and with that in mind, how do I validate each of those possible things? Because validating the transaction of buying something is different than validating the transaction of paying a debt. And so you can actually specifically write your custom logic in your code to do that. That being said, our last piece of the puzzle is flows. So a flow is sort of the means through which you can execute transactions. I described to you guys earlier that a flow is that a contract lets you validate a transaction. A flow is the way that you actually trigger a transaction. So if we both have our Corda nodes and I want to sell you a car, I need to trigger a flow that might enable me to specify the car that I want to sell you. And then my Corda node is going to propose the update. It's going to check it. It's going to sign it with my private key, and it's going to send it to you, and you will check it again. And when we say check here, what we mean is your contract rules, the code that we run to validate a particular transaction. Both nodes validate it, both nodes sign it, both of us have to agree explicitly to the transaction we have. And then my Corda node, having been the initiator, will then sign it, take it and have the notary sign it. And then the notary will give it back to me. I will record the update and then give it back to you. So that's maybe a bit of a complicated example. And if that didn't make a lot of sense to you, I'd recommend taking a look at some of our earlier boot camps. Hopefully this made sense. But by all means, feel free to reach us either in the chat, which is down here in the chat if you have questions about that, or refer to our earlier boot camps, or just reach us on Slack. So again, this is just kind of this is more of a long-winded way to describe what is an intuitive process that if I run my own Corda node, you run your own Corda node, we need ways for our nodes to represent objects we care about, to validate what we can do with those objects we care about that have value, and then ways to trigger the computational representation of us negotiating an agreement, or my computer talking to your computer and saying, hey, this item is going to be sold from me to you. So we need to digitally represent that. And so that's where this idea of states, contracts, and flows comes in. And that's how we think about it. And so try to keep that in your mind as we go through some of the trickier pieces of it. So I want to jump into the next slide now and actually talk about tokens, right? So I want you to think of a token as just a representation of an asset. In the real world, a physical token might be like a ticket, right? We have a fun little coat check thing here, right? If you go to a coat check, you give them your jacket, the concierge says, thank you, and they give you a token that represents your jacket, right? It is only a token. It only has the number 605 on it. The token doesn't say black cardigan with blue buttons. The token only says identifying jacket number 605. And so this token is proof of a liability that the coat check has to you for that black jacket with blue buttons. And in the same way, you can create tokens within Corda that can be very useful, right? And you better not lose that token, because the first thing that coat check is going to say to you is it really yours? Are you sure? We have cameras. We have explicit ways that we would need to trace back through to verify the ownership of a token, which can be really nice. And this is where we'll start to transition the metaphor, and hopefully we don't lose you guys. So the question then is, what is a digital token? So a fair amount of people are probably going to say cryptocurrencies. This is true. Cryptocurrencies are a subset of the kinds of digital tokens you can create. But digital tokens also include many other things. This is actually kind of a limited view of how to think about what tokens really are, especially in a blockchain context, because digital tokens also include all kinds of tokenized assets, right? As just a great example, you can have a single person who owns who has a deed to a house, which would be a token of ownership to a particular home. And that token relationship can also change a little bit, where let's say you could have multiple people who own a home, or renters, perhaps you could say, or people who've decided they're going to live together and split the cost of owning the home. So just keep in mind that digital tokens are much more than cryptocurrency, and they can represent other tokenized assets. So when you buy a stock, do you always request a paper stock certificate? You don't, right? When you use something like Robinhood, you actually accept the fact that you're not always going to have the physical stock certificate in hand, and you're fine with that. If you're buying call contracts or something like that, it's a great example. You're going to own a digital representation of an asset, and what you have is a liability in the future. So while today is not exactly a workshop on tokenization as a principle, we'll jump into what Corda can do for you in the examples I've outlined for you so far. So again, what is a token on Corda? It's not a cryptocurrency. It's a digital representation of asset ownership that is uniquely and manifestly different from the asset itself, right? A contract outlining that someone owes you $60 is a different thing than the $60 themselves. And that distinction is going to be very important for getting through this today. And a great example, a bearer instrument, right? A bearer instrument of a stock or something like that represents a liability between the issuer and the owner. So what does a tokenized economy look like if you're using Corda? A few good things. You'll get maximum security, right? You have peer-to-peer transactions over a decentralized network, providing you the highest security you can get, right? You get easy traceability, right? Any user can retrieve a credible history of any ledger asset with confidence, whether that is a token or a state object itself. You can trace that all the way back to its original issuance on the blockchain. This is really nice. You get the immutable characteristics and provenance of this blockchain that allow you to pretty much find out about any particular asset whenever you want. And, lastly, you get the increased liquidity and market access, right? Illiquid assets can now be represented digitally and traded as a whole or fractionally over markets, which enables new sets of owners. As a good example, maybe if some of you have seen a recent trend with brokerage firms allowing you to purchase fractional shares. You can, for $1, own a piece of Berkshire Hathaway, and the dividend is also fungible. It gets split up to all of the owners as a proportion to the actual amount of that stock that they own, which can be really fun. So you get a lot of really interesting use cases that I'm sure you all can imagine, even outside of the finance context. And hopefully you'll get some of that inspiration as we jump through these. So let's just talk briefly. We're going to get under the hood of the Corda Token SDK. We're going to do a quick overview. We will talk about fixed versus evolvable tokens. We'll talk about fungible and non-fungible tokens and what that means. And we'll talk a little bit about management. So just as our quick overview, the Token SDK provides a standard library to create and manage tokens in Corda, right? Fair enough. So you get some critical abstractions out of the gate. You have the ability to create tokens, which create the underlying token types for those tokens. Those can be fixed or evolvable. And again, those are fixed tokens, meaning something like currency, USD, or an evolvable token like a house or a car whose value changes with time, and other attributes of it change with time as well. So you can create those kinds of underlying token types. You can issue tokens, right? Reasonable enough. You can issue tokens to the designated holders of them, right? If I purchase a stock from you, then you would issue me, you could perhaps issue me a token for the stock that you now have a liability to me for. And of course, you can move tokens around. I can then sell my token to someone else if someone else wishes to own that stock. And I can redeem them. I can destroy the token representation and claim the asset itself, which is quite nice. And these come out of a few critical jars you're going to want to be aware of, which are token-contracts, token-workflows, and token-money. Thanks to Peter for the great icons here. So again, then the last thing, that redeem, which destroys the token representation and claims the asset itself. just to think back here again, you have the relationship between the ownership of the token and the asset itself. And so when you redeem a token, you are essentially saying, I would like to exercise this option, you might say, or I would like to actually claim the asset to which I have a liability. And so that's what redeem does. It removes the need for the token to exist as the liability is being satisfied. And so we remove the token representation and kind of de-link them and just have the asset itself change hands. So keep that in mind, that that actual liability is just removed and the asset is sort of just given to you. And again, it's equivalent to simply claiming the stock itself from Robinhood instead of owning the digital representation. So we've drilled this a little bit, this idea of fixed versus evolvable tokens. So the last time I'm going to hammer this, but keep in mind, fixed tokens are things like currencies that are easy to think about and do not change fundamentally, whereas evolvable tokens do change. Something like a house or a car whose value can change with time. And like a Corda state can be modified, and you can outline in your code exactly how evolvable tokens can change with time. So let's do a little bit of a deep dive on this token type hierarchy so that this abstraction can become a little more clear. So we see the fixed token type on the left here. Actually, let me hide that for a moment. We see the fixed token type on the left here and the evolvable token type on the right. And our goal is to create token type objects. So with fixed tokens, we can just create a token type object. It's fixed. It does not change after the fact. But with evolvable token types, it gets a little more complicated, right? You might need to create a separate Corda state to store all the actual evolvable attributes. So in the example we're going to show you, you will see and create a Corda state called house state, which is an evolvable token type state. And it has some evolvable attributes. Hopefully, this now makes a little bit more sense. Sorry, I showed it to you guys a little too soon. So try to keep this concept in mind, that an evolvable token is something that changes with time, fixed tokens being fixed, and within any evolvable token type, a state you can define yourself, at any time you can create a token pointer that can then be used to produce a token type that you can use all of the convenient subflows that we provide for you on. And you speaking of Corda states, right, if you want to actually drill down the path of what exactly is happening within evolvable token types or evolvable states, just like you would have implemented queryable states, evolvable states are like linear Corda states, meaning they change as time moves forward in a way that you would intuitively expect. Now, the good news is that you don't necessarily need to worry too much about that piece of it, because all of these white boxes here are intended to represent things that are within the Corda standard library or Corda core. So you don't have to worry too much about knowing exactly how that works. You should be good if you can keep these token differentiations in your mind. So again, that's two token types, fixed and evolvable. And a fixed token type is what we are referring to here when we say token type. That what we're talking about with evolvable is the only one that needs to have some fundamental shift through token pointers to become token types, if that makes sense. That's why we don't have a fixed token type class here, but we do have an evolvable one, only because there's no need for the additional abstraction. So an evolvable token type, again, essentially a linear Corda state that can be converted to a pointer. So all of that being said, I'm now going to jump into IntelliJ to show you an example of this in action. If you are wondering what we're actually looking at, I'm going to be pulling up some code examples from the $to house token CorDapp, which you can find on GitHub. I will stick this link if you are interested inside of the inside of the YouTube live chat. Let's see if this works. There we go. All right. So you can feel free to take a look at this if you like, and I'll tell you where we're going to be. Highly recommend as well, maybe either during this process or during this workshop or after the fact. I recommend trying the web IDE. You should be able to just click this button and get an instance of this CorDapp running inside of a cloud IDE where you can really explore the code base and make edits and try a few fun things. It's a really cool project, and our good friends Chris and Anthony at the R3 side have done awesome things with it, and we're very glad to have it. So definitely take a look at that if you're interested. So I'm now going to jump into IntelliJ, and I'm going to show you guys house_state.java. So I'll give you guys a few seconds to pull that up if you would like. All right. So public class house state extends evolvable token type. This is not surprising. So we've described earlier about how a house is like an evolvable token. Its value changes with time. And one of the important things to be aware of with this, a few notable differences between this and the typical and a typical Corda state might be that here we have a list of maintainers instead of participants, and we're required to have a unique identifier that is the linear ID. But with respect to a typical Corda state, these things are not super surprising. We have an amount of currency, which is the valuation of the home, a number of bedrooms, a construction area, additional info if relevant, and an address of the house. And so here we are, right? The constructor pretty much follows that. Nothing interesting going on there. We have our getters that do all of what you'd expect. Fraction digits is one thing worthy to note. This refers to the number of significant figures that you are tracking. This one is part of the interface as well. So for example, with regular currency, it is 2, fraction digits of 2, and with Bitcoin, it might be 8, let's say. So then, of course, we have our get maintainers, which just returns the list of maintainers. So it's not super different for those of you who are used to just implementing get participants. And then the thing to note here is actually the method that returns the token pointer by using the linear ID of the evolvable state. And so that is how this relationship exists. This token pointer gets returned by calling toPointer, which uses the linear ID of the house state in order to create a new token pointer out of it that can be used for the token type subflows in convenient ways. But you can see that it's not a lot of code. We haven't changed very much here. So with this example, it will probably help you to get to most of the use cases of things you'd want to represent. It's a fun example, so I recommend it. And if you are looking for this, it is right over here inside of contract source main Java net Corda examples dollar to house token states then house state. Should have said that first. So sorry for any of you who are trying to follow along. But that is where that code is. And the big takeaway of this is really going to be this token pointer abstraction.
David, I think we might lose your audio a little bit. Yeah, I cannot hear you.
Oh, really? Let me see if I can figure that out. Not sure what I can try. Peter, maybe you can tell me how much I missed. Are you still able to hear me?
I think we are good to go.
All right. How far back do I need to go? Hopefully I didn't lose anybody. All right, fair enough. Sorry about that if the audio got messed up. Did not even know. So
No. Just keep going. I think we are good on the YouTube side.
Cool. Thank you. Awesome. All right. So sorry about that. Just take a quick look on the just take a quick look at that house state. There's nothing too crazy happening here. Most of it's pretty intuitive, just a few small differences from an implementation perspective, but it's nothing that should take you too far away from the typical Corda abstractions you're probably used to. And if you're new to Corda, then hopefully some of this is intuitive to you. So continuing back with our slides here, the thing I want to focus on next is actually not the fixed and evolvable, but actually to move to the fungible and non-fungible. So just to drill down this separate piece of the question here, there are fungible and non-fungible tokens you can represent within Corda. And some of them, such as fungible tokens, are things that can be divided and can be combined to have equivalent value to the divided asset. So for example, if I have a $100 bill, that can be split into 100 $1 bills and have the same exact value, meaning currency is fungible, whereas something like a house is not fungible. If you were to split a house in half, it would not have the same value as a house that was fully combined, right? So you can't split a house generally, but it all depends on how you want to define the abstractions as you want to think about them. So both of these kinds of tokens are kind of sub abstractions from the idea of an abstract token, which itself is an extension of the contract state uh, idea that we use when normally thinking about Corda objects. So I'll show you guys some quick examples in IntelliJ of creating a house token, and then we'll contrast that with creating a fungible token, and hopefully it'll make sense. So the next place I'm going to jump is the house token create and issue flow.java. So that's all the way over here. It's going to be not in contracts, but inside of workflows, source, main, Java, net, Corda, examples, $house token, flows. Then you will see 4 different flows here. We're going to be focusing on house token create and issue flow. So this is a flow that's going to be running. This is someone whose Corda node. Let's say I'm a bank, and I'm going to create for someone a house token. So my Corda node will run this flow. So it's not surprising that there will be a party to the transaction that's the owner. We'll have the valuation of the house. Some other things that make sense that are required to create the house state, which are the number of bedrooms, construction area, additional info, and address. Moving forward with that a little bit, the actual constructor itself does a lot of what we'd expect. It takes the owner, it takes the valuation, it takes the number of bedrooms, and uses all of these when the flow is actually called. Within the flow's logic itself, it does a lot of things that you're used to. It starts by choosing the notary for the transaction. It gets a reference of its own identity for the issuer, rather. It creates a unique identifier, and it creates the house state. And so far, none of this is anything new. This is all stuff we've seen before. It is only when we start. It is only when we get to creating the token that things get interesting. So we've created the house state itself, which is the Corda object, or the representation of the physical asset, and that again is separate from the liability or the token for that asset's value. So the token itself is created a little bit lower. The next thing we do is create our transaction state using the house state object we created, the asset, and the notary. And then we create the actual house token itself. The token SDK provides the create evolvable tokens flow. So you can use that to create the actual evolvable token in the ledger. So that's where this subflow comes in. We're using that transaction state to create an evolvable token from that. And so now we get to the point where we see we have an instance of a non-fungible token that we're calling house token, which is equal to a non-fungible token builder of token type. And we use that house state, call the toPointer method that we defined over here to get a pointer to the house state that we can then create a token from. Right over here. And when we use that, we can then specify the issuer of the token and the owner, and we can use the build non-fungible token method to truly create a meaningful non-fungible token for this house that we want to represent. And then we finish the flow out by signing the transaction and then calling the subflow for issuing the tokens. Note this is a specific subflow to token methods, but it should work for you. Hopefully you won't have any difficulties with this if you're used to collect signatures flow or a finality flow or anything like that. It shouldn't be too different as far as getting this working. So hopefully that makes sense. And then on the other side, so we've seen the more complicated instance of creating a token for an asset that is separate from that token, right? And then on the other side, the other thing I want to look at is the fiat currency issue flow. Same folder over here, top of the folder, main Java, inside of workflows, fiat currency issue flow. This one is similar to what you expect. This issues fiat currency. It creates a representation of currency. And so it's not surprising that what it needs is the currency, the amount, the recipient, and the flow requires those three things within the constructor. And when it runs, it starts by creating a token type. It then creates a fungible token using the fungible token builder of token type, based on what we've used here. And in this case, we have a helper method that is worth outlining a little bit. When the flow runs, it uses this helper method to get the type of the token as a function of the string we pass to the flow when we run it on the command line, which is USD, GBP, EUR, etc. Whatever string I pass to the flow will simply use this helper method to get the currency it's going to use, so that when we have the type of the token, we can pass it directly to the fungible token builder with the specific amount. We issue it by our identity. That's nothing new. We are the ones issuing it. It is going to be held by the recipient of this transaction for this token. And then we finalize this by calling the build fungible token method. And then, of course, we use the same subflow tools provided to us by Corda. So we'll use the new issue tokens flow, and we'll pass the immutable list of fungible tokens and the recipients. And that's really it. That's really all that goes into it. It's about 70 lines, even less if you don't count the imports. And that will get you to a place where you can issue tokens to yourself for currency, or for fungible assets, or for non-fungible assets like houses. And it's worth emphasizing as well that this is up to you. We by no means have any control over how you wish to semantically use these tools. If you would like to represent tokens for a house that are fungible, to represent something like multiple renters, you are free to do that. And we are only giving you, I just want to emphasize that we're only giving you possible use cases, and that you're free to take this in whatever direction you want. So I'm going to jump back into the slides here. Now that we've kind of outlined all of that, I'll give you a quick overview of the actual token SDK built-in subflows that we provided for you. These are a lot of the things you'd expect, so we're just laying them out for you here. This is just reinforcing the abstractions we were talking about before. The subflows to create tokens, the subflows to issue tokens, the subflows to move tokens, and the subflows to redeem them. And lastly, of course, the subflows to update them. And so you are free to look into any of these methods within IntelliJ or online to make sure that you are using the right flows or the right subflows for your particular use cases. And so now that you have this idea, you can start to see what the potential use cases are really going to be, right? To kind of summarize, right, there's a lot of different types of tokens. You can tokenize, for an example of an evolvable fungible asset, you can have something like tokenized real estate property rentals like we were describing before. Maybe I have multiple people that all share ownership of a home. So there is a fungible tokenized real estate evolvable token that they might all want to be able to share and exchange or buy off of each other, etc., that are all linked to a singular asset. And on the non-fungible side, right, another evolvable token, something that changes value with time, would just be unique ownership. A single person who owns a house might only need a non-fungible token for that, as an example, right? But on the fixed side, something fungible could be our canonical example from earlier, which is digital dollars or something like that. And then something non-fungible would be something like a gold brick, right? You can create a token for a gold brick, but you're not going to really be separating precious metals anytime soon, I suspect. When it comes to other types of assets that you can also use this for, of course, there is any kinds of on-ledger assets that you want to create tokens for, such as a security that you've issued on a Corda network, such as a digital token representation of a stock certificate. And on the off-ledger side, there are real-world physical assets, such as a house in Manhattan, right? And that is something in the real world that you can represent with Corda, which is really powerful. So now that we've kind of outlined all of the use cases, we've gotten the right abstractions into our head, I think my recommendation for all of you at this point would just be to try it for yourselves. So here are some links to the Java and the Kotlin versions of our samples repos, where I got the example that we looked at today, and you can get many others. We have some other great examples, such as the fungible house token, which serves as a basic example for creating, issuing, and moving fungible tokens in Corda, utilizing the token SDK. That's the one we looked at today. There's another one which is aiming to demonstrate the usage of the token SDK representing stock, which is another classic example for something like this. Then there is, of course, the bike market, which has a few more different operations and a more in-depth sample that might be worth looking at for if you have a more nuanced or complex use case. And if you are interested, as always, Corda is open source, so you are free to take a look at the Corda token SDK source code, and you should have no problems taking a look at that on the link here. So, all of that being said, if you're ready to build, we're here to help you. I recommend taking a look at the free training sites. I recommend taking a look on Slack. I recommend looking at the Corda documentation. You can find the source for all of our projects on GitHub. You can email me and the rest of the DevRel team using the email contact devrel@r3.com. We're on Twitter at Corda Blockchain and at Inside R3. And of course on YouTube, where you are now. Please do rate and subscribe the video and click the little notification bell. It helps us out. And yeah, I think for me, the thing I would most recommend is actually just signing up for our Slack. Peter and myself run office hours every Tuesday and Thursday from 3 p.m. to 4 p.m. Eastern Standard Time. And if you're in other time zones, we do have other office hours that other members of our team, Ashutosh and Sneha, run as well. So I recommend reaching out to us. It's a free community, and we're always there to help out if you have questions or you're having trouble. So please do feel free to reach out to us. We're always happy to talk to you. And just as a final thing before we let you guys go, we want to get a quick sense. Are you guys professionals or are you learning Corda for your own interest? If you could just type a capital P or a capital L in the comments, that would be really great. And that would mean a lot. Yeah, so we are constantly working on how to improve, better ourselves, and grow as a team and help you guys grow into the use cases you're trying to implement. So by all means, if you have any feedback for us, there's many ways you can get in touch with us, and we're always happy to hear from you. So hopefully this was useful for you guys, and we are very happy that you guys came through. So thank you very much for that. And yeah, so by all means, check out r3.com, corda.net. We're on LinkedIn, Twitter, and there are plenty of ways to get in touch with us if you need. So if you have any questions, hopefully Peter and I will still be there in the chat for the next couple of minutes, and we'll be able to answer all of your questions. So I think we can call it at that, and we'll be around. Let me take some of these links and post them into the chat as well, just in case. No? All right. Yeah, Peter, I think we're all good. So like I said, everyone, thank you again. We'll be in the chat, and we'll be happy to hear from you if you have any other questions.